Okay, so we've made our graph. So what we're going to do in number 3 is we're going to see if we were going to try to connect the dots, and let me go back to 2.1 here. So this is the age of a child and annual cost. If I were going to try to connect the dots, well, if I did a line, it wouldn't quite hit through all of them. But the question that I'm trying to figure out is, what could I do that would get maybe close to it? If I were going to draw a line, let's say something like that, for instance, I want to know what's the equation of that line. In terms of y equals mx plus b, what's the slope of this line? What would the y-intercept of this line be? So that's what I'm wanting to figure out. So we're going to do it first by hand in question number 3, and then we're actually going to have the graphing calculator do the number crunching for us in question number 5. But we want to be able to do it by hand, and then kind of compare to see what the calculator comes up with. So let's go back to number 3. So as I said, and you may want to write this down, try to squeeze it in somewhere on the page here, and we're going to refer back to this. But the equation of a line is most commonly written as y equals mx plus b. And what the m and the b represent, the m represents what we call the slope, which for a lot of you, you've got programmed into your mind, rise over run. Well, that's true to an extent, but I think what you'll see here is we really want to conceptualize this as what we'll come to see as the rate of change. And once we actually get this set up, I think it'll make a little more sense. The b represents the y-intercept when we graph. But in a context of what we're going to look at here, you almost kind of want to think of this as the starting point. So, if I could maybe just even already talk about this. So I've got the child age at 3, it's going to cost me $10,700. Well, what the b represents, or the starting point, would, at least in this problem, would tell me, well, how about when the kid is born? How much is it going to cost me then? Right? So that's what we're talking about as far as the starting point. The slope, in terms of the rate of change, I can see that this is going up. Right? It's getting more expensive as the kid gets older. But what the slope is telling me is it's telling me the rate of change. How much is it going up by? So that's really all I want to know is that how much is it going up by each time, right? Each year the kid gets older, and what's it start at? Because we started the table at 3. Well, I want to know what's it going to cost me, when it's a newborn. So that's what we want to figure out. All right. So how do we figure out the rate of change? Well, we got to pick 2 points and figure out how it does change in between those 2 points. So the problem actually tells us 2 points to use, and just so we can kind of keep the numbers clean and consistent. So they say use age 6, which will be those numbers, and use age 9. So our 2 ordered pairs are going to be 6, 11,700, and 9, 12,600. So what we're saying is that if we want to know, well, how much does it change by, well, we're going to compare these 2 numbers. How did it change from when the kid was 6 to when the kid's 9? Well, how we figure out the rate of change is that we're going to compare, and here's a little bit of a formula here that you'll have to know, but hopefully this will make sense. Y2 minus Y1. What that's saying is that we want to compare how does it change in terms of, first of all, the cost, right? So from a 9-year-old to 6-year-old, what's the difference in cost? So the Y2, 12,600, so we'll say 12,600 minus, when it was younger, he or she, 11,700. And then what we want to do is then say, okay, over what period of time was that? Well, we're starting when the kid was 9, and from when they were 6. So we're comparing the difference there between those 2 things. So 12,600, and by the way, we'll be using the calculator here. Not that we couldn't do this mentally or by hand. But I think what we're going to want to do is that we want to really be thinking about what we're doing in the problem and not make any sort of little arithmetic mistakes. So we'll have the calculator there for us. And then 900 divided by 3. So what that means is that the cost is going up by, or at least, looking at these two numbers, is going up by $300 per year. So that would be our rate of change, is that it's going up. Because see, the table jumps from 3 to 6 to 9. So yeah, I could say, yeah, over 3 years it went up by 900. But what I'm looking at is, again, an annual cost. Well, the annual cost would be 300. So my rate of change here is going to be y equals 300x plus, now I just want to know what my starting point was. Again, that's kind of going back to say, like, well, what was it when, in the first year, really, of life, how much would that cost? So what we want to do is that, and it doesn't actually matter which one we pick, but we'll pick one of the pairs here. So I could pick the first pair, or I could pick the second pair. But what I'm going to do is I'm going to plug it back into the equation, y equals mx plus b. And I'm just going to use the first one here. So they tell me the y is 11,700. And then we know what the annual cost is. The annual cost is 300. And the x, we're saying, is 6 plus b. So the way that I can translate this is that it's saying that it's $300 per year plus whatever the baby cost from the very beginning. That's going to equal 11,700. So basically what I'm doing is I'm taking what I already have, or what I already know, and I'm just going to be solving for b. So 11,000, let's go back down. So 300 times 6, well, that give me 1,800 plus b. And then I'm going to subtract 1,800 from both sides. So minus 1,800. And so that would give me that b is equal to 9,900. And if you weren't sure about that, you could have, certainly could have gone into the calculator, maybe double check our numbers here. 11,700 minus 1,800. And I do get 9,900. So I want to put all that together, and so I've got 9,000. Let me erase that. 9,900. So again, we want to interpret this in context. So what this is saying is that in that first year of life, the baby's going to cost you 9,000, or at least according to these numbers. In that first year of life, the baby's going to cost you 9,900 plus $300 each year, right? And one thing you might see sometimes, and actually this makes a little bit more sense to me, is that we write this y equals mx plus b, but sometimes it makes more sense almost to put the y-intercept first, or the starting point first. Because if it is the starting point, then why wouldn't we write it first? So you could also write y equals 9,900, because that's the starting point, plus 300x, which is the rate of change. So formally, how you're going to most oftentimes see it is y equals mx plus b. But I want you to know that you may see it this way, or if you choose to write it that way, maybe that makes a little bit more sense to you. All right, so what you're going to do is that you're going to use the same formula here, y2 minus y1, x2 minus x1, to figure out the slope. Once you know the slope, pick one of the points. Doesn't matter which point you pick. Pick one of the slopes. One of the points to find the y-intercept, the starting point, and then you want to write the equation of the particular line that's there. All right, so go ahead and pause now and try 3.2 in the middle, and then 3.3. All right, so let's check to see what you got for 3.2. So for 3.2, you should have got y equals negative 4,200x plus 797,000. And the reason why that slope, why the rate of change is a negative 4,200, is that if you remembered our graph, what it was that it was going downhill. So what that means is that as you move away from the city, the price is actually going down. It's getting cheaper. So that's why that slope would be a negative. The 797,000, what that's saying is that's the starting point, or at least, again, according to these numbers. So that's the starting point. Like if you're right there in the middle of all the action, then you could expect to pay that price. And then as you move away from the city, the price is going down by $4,200 per mile. On 3.3, so we got y equals 15x plus 80. And what that's saying is that, again, this was our example of sandwiches, and that the more fat you have in the sandwich, the more calories it's going to have. So what it's saying is that something that's fat-free, right? Because even if something's fat-free, it still has calories in it. So what it's saying is that the starting point would be 80, even if it was fat-free, plus then what you're throwing is 15 calories for each gram of fat. So that's the rate of change, that it's going up by 15 calories for every gram of fat there. All right, so let's go ahead and stop the video here, and we'll go ahead and move on to number 4.